So today we're going to start doing exponent problems, and hopefully these won't be a lot of stuff you haven't done before. We'll see if these start feeling familiar, especially with some of the CASI that review that we did had these properties. So let's look at one property, which is the product of powers. Okay, so the product of powers property would be if you have some number to a power times some number to a power, that is the same thing as that number to the sum of the powers. Okay, so for example, if I have 3 to the 5th power times 3 to the 2nd power, my property says that should be 3 to the 7th power. I'm just going to demonstrate a few times why it works, but of course you don't have to do this full demonstration like I'm going to do. 3 to the 5th power is 3 times 3 times 3 times 3 times 3 times 3 squared is 3 times 3. So that's 3 to the 1, 2, 3, 4, 5, 6, 7th power. I didn't have to write out all those 3's. If I just add 5 plus 2, I'll get that 7th power. Okay? Yes. Yeah, this is stuff from elementary school. So, yes. All right. So now I got 3 of them. I got 9 times 9 squared times 9 to the 3rd power. So I need to have every one of those 9's, which are all called the bases, all have a power, an exponent. So this first 9 doesn't have an exponent, and I wonder what that exponent would be. Shh. Stop yelling out, sweetie. This first 9 does not have a power to it. I wonder what the power would be. 1. This is 9 to the 1st power times 9 to the 2nd power times 9 to the 3rd power, making this be 9 to the 6. 1 plus 2 plus 3 is 6. Okay? And we have to think about doing this with negatives. So if I have negative 2 times negative 2 to the 7th power, that's negative 2 to the 1st power times negative 2 to the 7th power. If those negatives are in parentheses, leave them in parentheses and get negative 2 to the 8th power. If you take the parentheses away, you're going to change the value of that, and sometimes you'll be correct and sometimes you'll be incorrect. Now, we don't just have to have numbers as bases. We can have variables as bases as long as they're the same. If I have x to the 4th power times x to the 3rd power, that's x to the 7th power. Okay. And now we'll get just a little bit. Oh, now we get to use the other property. Power of a power property. Okay. So if I, the power of a power property says that if I've got some number A to some number n power, and I put parentheses around it and raise it to another power, that is A to the, don't add them, multiply the exponents, n times m power. And how does that work? Well, let me give you one demonstration of how it works. So if I go 3 squared to the third power, that means I take 3 squared and I do it 3 times. That's what that third power means. And 3 squared times 3 squared times 3 squared is 3 to the 2 plus 2 plus 2 is 6 power. Well, all I really needed to do to get that answer was just multiply the 2 times the 3 and get the 6 power. That's fine. Good. Okay. His tutor has the assignments, so we can do it.
My tutor does not have the assignment.
Oh, he doesn't? Oh, I haven't given the assignments yet. Sorry. You're right.
He does not have. Yes, I do. Is that an issue? Oh, no. How do you get it figured? Because my mom thinks I need it.
Okay. So this works with variables. So if I have, shh, guys. So if I have x to the second power to the fifth power, that's the, shh, that's x to the 2 times 5 is x to the 10th power. I can do it with negatives. If I have negative 6 to the second power, all of that to the 4th power, that's negative 6, leave it in its parentheses, to the 2 times 4 is 8 power. And if I have a binomial like x plus 4 to the second power to the 10th power, then that's what's ever in the parentheses, guys. That's what's ever in the parentheses, x plus 4 to the, multiply the powers, 2 times 10 is 20. Okay. So